Hi, so one of the first topics we're going to cover is an introduction to science. So I've provided these notes. Some of the videos will have notes where you can write down what I'm saying or what I'm talking about in the PowerPoints, just so you can keep track of what's going on. So you're strongly encouraged. You're not required to print these things out and write on them, but it really will help you keep focused and on target and give you something useful to study from. So, what is earth science? Earth science is the study of the earth. Now, the thing is, that's a pretty obvious answer. It's named to earth science. It's the study of the earth. But what does that entail? Earth science is actually what's called an interdisciplinary science. It's actually more than one science added in together. So some of the sciences that we'll be looking at that are part of earth science include geology, oceanography, meteorology, and astronomy. Now, what's geology? Geology is the study of the physical earth. So we're talking rocks, mountains, minerals, volcanoes, all that sorts of stuff. Oceanography is the study of the Earth's ocean. Meteorology is the study of climate and weather and anything that's going on in the atmosphere. And astronomy is the study of stars, planets, and the solar system. Now, what makes earth science different from other kinds of science such as physics and chemistry, is that it's not necessarily a laboratory science. We do laboratory experiments in earth science, but most of earth science takes place outside. So in physics and chemistry, what you do to do an experiment is you go over to, I have a little fume hood over here. You go over to the fume hood over here, and you take a bunch of chemicals, and you would play with the chemicals all inside your lab. But you can't do that in earth science, because what we're doing in earth science has to do with things like volcanoes and tornadoes and the moon. And you can't bring volcanoes and tornadoes and the moon into a laboratory environment. Bring little models in, but to really understand them, you have to look at the phenomenon themselves in their natural environment. Now, earth science is a science, and the unifying principle for all sciences is the scientific method. The scientific method is a very powerful method to coming to the right answer. It's not the only way of thinking about the world. There's artistic ways and there's religious ways of thinking about the world. But the advantage of the scientific method is it gives us a very, very powerful tool to reject incorrect answers, to reject wrong answers. Unlike other ways of thinking, we can get rid of incorrect ideas by simply showing that they do not work. Now, what is the scientific method? Well, in your book, it's listed as a 5-step process, but there's a 0th step that I feel is really important that a lot of texts and online materials don't talk about, and that 0th step is to learn the science. It's not really a scientific way of thinking about things if you haven't gone out and done at least a little bit of research on what other people have tried before and what their results were. Then, from what you've learned, you develop a question from the observations and what you've learned, and then you provide some sort of an explanation, a hypothesis. Now, what is a hypothesis? A hypothesis is an educated guess. And that's really important because it differentiates between a hypothesis and what we're going to talk about in a few moments, which is a theory. Now, you predict the results that you would expect if your hypothesis were true. You do experiments, so you make observations. So if we're working in chemistry or physics, we'd go into a laboratory and we'd have it all nice and neat and organized and super clean. And we'd do some kind of physics or chemistry experiment and we'd be done. In earth science, we would predict what's going on in the natural world. So what we would expect a river's shape to look like, what sorts of rocks you would find in a particular location. We put on our boots, we go stomping out there in the mud, and we collect those observations. Then we take those observations and those experimental results and we compare them back to our predictions. If they match our predictions, bang, we can accept, at least temporarily, our hypothesis. Now, it'll take a lot of different trials to make it a real, genuine, accepted idea in science, but it's past the first step of the scientific method once it goes through that collection of observation and comparison to our predictions. Now, the word hypothesis is often mixed up with the word theory. Very often, people will say things like, I have a theory about that, when what they mean is, I have a guess, or I have a guess based on evidence. That's not really a theory in scientific terms. It's actually more like a hypothesis. A hypothesis is an educated guess. A theory in science is something that's been tested a lot of times to be true, and every single time has been shown to be true. So a couple of good examples of that. Atomic theory, the idea that everything around you is made of atoms. I'm pretty sure that everyone watching this video accepts that the whole world is made out of atoms, little tiny indivisible pieces of matter. Gravitational theory. Gravitational theory says the same force that makes your pencil fall when you let go of it is the same force that keeps the Earth in orbit around the sun. Now, I think all of us can agree that gravity actually genuinely exists. Now, there are some theories, such as evolution, that some people have a little bit more trouble with, and they tend to grab onto that idea of that it's a theory. But when we say theory, we mean something accepted by scientists to be true. And it's important to understand that things like plate tectonics and evolution are just as accepted by science as atoms and the presence of gravity. So, I hope you've enjoyed our little introduction to science. Let's keep on moving into our next subject in this course.